Hi guys, welcome to this screencast. So we're still in the respiratory system. What we're going to be looking at today is gaseous exchange. Okay, so we're going to be going through how we're going to answer a question on gaseous exchange. So this is the same process as before. We're going to look at the question that's been set. We're going to circle important information, which I'm going to give you. Memory method, hopefully going to give you that as well with the translation. And then we're going to be able to actually answer the question to get the full marks that are required. Okay, first of all, let's just quickly go through the structure of the respiratory system. We're not going to go through the function. What we're going to go through is quickly the reason we're doing this is because we've already spoken about the mechanics of breathing, which we're going to go on a little detail here to then actually finally get to the gaseous exchange process. First of all, we breathe air in, okay, through the nasal cavity, okay, as well as the mouth as well. It comes down here and around here. We've got the pharynx we should know about, and we've also got the larynx. Air comes rushing through the trachea, down the bronchi, into the bronchioles, which are these branches here, and then finally into the alveoli. So we've just breathed air in from the mechanics of breathing. Now we've spoken about how the diaphragm contracts and flattens the external intercostal muscles. So intercostal muscles in between the ribs, the external intercostal muscles contract. This means that the ribs move up and out. Thoracic cavity volume increases, the pressure decreases, air rushes into the lungs. So now that we've got air into the lungs, what do we want to actually happen? Well, we need to get the oxygen from the air into the bloodstream to then deliver that to the muscles. When we breathe out, we want to actually get rid of the carbon dioxide that has been transported back to the lungs and breathe that out. And that's the process we're going to go through today. So just imagine quickly that we've breathed in air through the bronchi, through the bronchioles into the alveoli, which we have here. Now, let's just say these alveoli here are full of oxygen. They're rich with oxygen, loads of oxygen within there, okay. Now, all that happens is the blood that's currently in the lungs is deoxygenated. There's no oxygen in there. So what all that happens is when the blood vessels wrap around these alveoli, the capillaries wrap around the alveoli, the gas exchange is oxygen goes from the alveoli into the bloodstream and then gets pumped around the body. The blood that's coming back to the heart, so returning back to the heart, is full of carbon dioxide because it's been diffused at the muscles into the bloodstream. So it's full of carbon dioxide here, and then all that happens here is carbon dioxide swaps with the oxygen at the alveoli. The carbon dioxide then goes into the alveoli, and then we breathe out carbon dioxide. And that's the process of gaseous exchange, which we're going to go on about now in more detail, and hopefully give you the kind of structure you need to answer a question. First of all, I want you just to quickly look at this and fill in the blanks. So gaseous exchange between the alveoli and blood. The reason I've highlighted the alveoli and blood is because that is the only place you need to know about when it comes to gaseous exchange. All you need to know is it's between the alveoli and the blood. The alveoli is in the lungs, and the blood vessels, capillaries are around the alveoli. So all we are interested in is the gaseous exchange at this point here between the alveoli and the blood. So what I want you to do is to fill in the blanks here and then we'll go through it together. So can you pause now and give that a go? So first of all, we try and look at this, well we 100% look at this at one gas at a time, okay? We don't try and confuse it. We get given a question, we do one gas at a time. So what we're going to do right now is gas one, we're going to talk about oxygen now. So first of all, the gas is oxygen is what we're talking about. The area never changes, it's the alveoli and the blood. Special rule, gases move from an area of high partial pressure to an area of low partial pressure, i.e. they move from where there's loads of gases around to where there's hardly any gases around. Partial pressure, so we've just breathed in air from the atmosphere into our lungs, into the alveoli. So there's a high partial pressure of oxygen, i.e. there's a lot of oxygen in the alveoli, and there's a low partial pressure of oxygen in the blood because the blood that's returning back to the lungs is full of carbon dioxide, it's not full of oxygen. That's why it's going back to the lungs so we can get oxygen involved there. This creates an oxygen diffusion gradient, basically just saying there's loads of oxygen there. What does this mean? This means that oxygen, this is the key guys, oxygen diffuses from the alveoli into the blood, and then from there it goes to the muscles so that the muscles can get the oxygen that's needed. Once you've done gas one, we now need to think about gas two. Gas two is carbon dioxide. We only care about oxygen and carbon dioxide. So gas two Carbon dioxide, the area, it's still the alveoli and blood. Special rule does not change. Gases move from an area of high pressure, partial pressure, to an area of low partial pressure. Partial pressure of carbon dioxide we're talking about now, because that's the gas we're talking about. So partial pressure, high partial pressure carbon dioxide in the blood, because it's exchanged from the muscle into the blood. It goes back to the heart and back into the lungs, full of carbon dioxide, the blood does. We've got a low partial pressure of carbon dioxide in the alveoli, because the alveoli is full of oxygen, because we just breathe oxygen in. This creates a carbon dioxide diffusion gradient, which means carbon dioxide diffuses from the blood to the alveoli and we breathe it out. Now that is the process of gaseous exchange. I'm going to give you a question in a minute and I'm going to give you a method of how we're going to remember this. Okay, so explain the process of gaseous exchange of oxygen at the alveoli during a marathon. Now they have literally given you the gas, haven't they? They've said they want to know about oxygen. They don't want to know about carbon dioxide. They only want to know about oxygen. Remember, as soon as you see a question, gaseous exchange, you've got to think gasp, gasp DD. Okay, so gaseous, gas, gasped DD. You're gasping for air. Gasp DD. So have a go answering that for me now, please. If you just pause it and give it a go. Now I'm going to go through the answer. Okay, so first of all, the G stands for gas. And what gas are we talking about? We're talking about oxygen. The A is area. Well, it's always between the alveoli and the blood. Special rule, gases move from an area of high concentration to an area of low concentration. That is it. Partial pressure. Now, the gas we're on about is oxygen, so we only need to talk about the partial pressure of oxygen within the first process. So we'll say the partial pressure of oxygen is high in the alveoli and it is low in the blood. The D diffusion gradient, this causes a oxygen diffusion gradient. And then the final D is diffusion, which means oxygen diffuses from the alveoli into the blood. 4 marks. That is as simple as it gets. Now, the next question I'm going to show you was the question that was in the exam paper in January. Now, I will give you a heads up with regards to this question. This is the answer, mark scheme, sorry, first of all, for that one we've just done. So, partial pressure of oxygen in the alveoli is high, partial pressure of oxygen in the blood is low. This creates a steeper diffusion gradient or an oxygen diffusion gradient. Oxygen diffuses from the alveoli into the blood. Simple as that. So, sorry it's a bit blurry. Analyse a gaseous exchange process that ensures Farzana sustains her performance throughout the 10,000 metre race. Now, one thing I'm going to say to you, they have not said whether you need to talk about oxygen or carbon dioxide. Therefore, you have to talk about both. So go through the gaseous exchange. You've got, okay, gaseous exchange, gasping for air, gasped DD. Get that down the side of your piece of paper, GASPDD. Now answer this question, but you have to answer it talking about both oxygen and carbon dioxide because they have not specified which one they want you to talk about. So talk about both, hence why it's worth 6 marks. So pause it and give it a go. Right, okay, now we're going to go through the answer with regards to the student's answer that was in the paper from January. Now, obviously, it's not very clear here, unfortunately, but give that a read and hopefully you can understand how you're going to be getting the gas DD marks with regards to both oxygen and carbon dioxide. Let's speak about oxygen, this part here, then let's speak about CO2 here. So give that a good read if you pause this, understand it, make sure you've got the key points that they've put down as well. And that is the process of gaseous exchange done, guys. Okay, so pretty simple for you, pretty basic. Remember the gas DD should be absolutely fine. So I'll see you later. Thank you. Bye.